Hello and welcome. So we're going to find the dimensions of a rectangle, given that the length is 5 inches longer than its width, and that the area of this rectangle is 84 square inches. So first off, let's go over what we know about rectangles. All right, if you have rectangles, what you know about it is it has 4 right angles. All right. You also know it has 2 sets of parallel sides, and the opposite sides are congruent, meaning the same. So we have a width, we have length. We also know that the area of this is 84 square inches, right? And remember, the area of a rectangle is the length times its width. So we have a couple of options here. All right, we can write our equation in terms of just length or just width. I'm going to write it in terms of just width because I like writing W more than L, right? We can do it either way. I'll show you what the equation would be otherwise. It's going to be really similar. All right, so for this one, we know that the length is going to be 5 inches longer, meaning 5 inches more than whatever our width is. So it's going to be the width plus 5. So now we can write our length in terms of width. Now, if you wanted to go the other direction, you'd say length and the width would be the same thing as the length, but 5 inches shorter. So you can write the equation in terms of just length or just width, whatever makes more sense for you to think about. All right, so now that you have kind of a lot of the information put down, now it's just a matter of relating it to each other. And our area is how we are going to relate it. We know that the area is 84 square units. We know that the length is going to be the width plus 5 inches more. And we don't know what the width is, so that's going to stay times W. Now, the reason why we related this all together is that when you look at that equation, how many different letters do we see? 1. It's just W, which means you can now solve this equation for W. All right. Now, remember, this is factored, and factoring is really only significant when it's equal to 0. So we need to undo that factoring, so multiply and distribute the W back through. So W squared plus 5W equals 84. Now, again, our goal is to solve, so we're going to want that 84 back on the other side. So 0 equals W squared plus 5W minus 84. Now, you can solve this using any method that you know for quadratics. I prefer factoring, so I'm going to ask myself, okay, what multiplies to negative 84 but adds to 5? Okay, well, what about 12 and negative 7? Yeah, that works. Excellent. So 12 minus 7 is 5. 12 times negative 7, negative 84. Booyah. Which means that we have W plus 12 and W minus 7 as our 2 parentheses there. Remember, you can go straight to your parentheses because 1 is your leading coefficient. All right, which means that now you would just finish solving, equal those to 0. And W equals negative 12 and W equals 7. Now, keep in mind, we're talking about the width. That's what our W stands for. Can you have a negative 12 inches as a width? No, it doesn't make sense, right? Distances, right? Measurements cannot be negative. Negative 12, that answer is not a valid answer. Now, 7, absolutely valid. Sure, makes sense. Now, I know that my width is now, you can say 7 inches. All right. Now, it wants us to put a whole number, 7's a whole number, yay, with units. So make sure you put inches into your answer blank as well. All right. Now, for the length, we already know how to relate the width to the length. We know that the length is the width plus 5 inches more. So in other words, 7 plus 5 is 12, and your length is 12 inches. There you go. There are the dimensions of the rectangle. Thanks for watching.